Hello everyone. By now you are well equipped. When I say well equipped, you know everything almost about functions. That is what you think. I mean, theoretically, we are well prepared. Now, don't you think we have to take some questions? So, in this session, we will have only problems on functions. Now, idea behind taking more and more problems, which you will see in following sessions also, on functions is that normally people do not pay much attention to unit function of calculus from problem solving point of view, I'm saying. And in all competitive examinations, topic function is extremely important, and hence variety of question is also unbeatable. Now you try more and more problems, and then you will understand the beauty of the topic. Topic function is extremely vast. It may not be perhaps possible also to take every possible question on function. But I'm so sure that if you go through all the sessions of problem solving, then you will have at least some idea that what variety you can have in topic function. Absolutely no two problems look similar. So let us start with the first one. And first one, I'll try to keep extremely simple one. Let us take that. If fxy equal to 3x square minus y, then we are asked to find f bracket minus 1 comma f 2 comma 3. This is what we are asked to find. Now when you read f at minus 1 comma f 2 comma 3, what it tells you? That I am given fxy. In place of y, I am writing f 2 comma 3. So your first step should be that I will have to find perhaps f of 2 comma 3. So what do I do? In place of x, I will write 2. In place of y, I will write 3. And I evaluate f 2 comma 3. And that turns out to be 9. Now, to get f minus 1 comma f 2 comma 3, now in place of f 2 comma 3, I will replace it by 9. And I will try to find f of minus 1 comma f 2 comma 3, and that would be nothing but 3 into minus 1 whole square minus 9, and it is nothing but minus 6. Comparatively, this question was extremely straightforward. Now, though I have made it multiple option, so my correct option is D, but the idea was that you should be able to find value of the function at some given value of x or y. Now let us move to next one. And the next one is that f is an even function and g is an odd function, and we are given one equation that fx plus gx is 2 raised to x plus 1. Then, and some 4 options are regarding fx or function f. Now, when you start the problem, this commentary you will everywhere find in my all sessions of problem solving, that you keep taking smaller and smaller units of that problem. Try to actually make postmortem of that problem, that how much ever small thing you find there, but you should use it. G is an odd function. When you see it, what you will think? That am I supposed to substitute that in place of x minus x? Because I know what is odd function, that g of minus x should be minus gx for odd function. Fine. That means, will I substitute x equal to minus x? Do that and get a new equation. And that is nothing but fx minus gx equal to 2 raised to 1 minus x. Now look at those 4 options. They are regarding f, not regarding g. So what comes to your mind? That should we eliminate g? In fact, that's the best thing to do, because in one equation you have fx plus gx, and in other equation you have fx minus gx. So best is you add them and get information about fx. And what do I get? That is twice of 2 raised to x plus 2 raised to minus x, or 1 upon 2 raised to x. 2 will get cancelled, and my fx would be 2 raised to x plus 1 upon 2 raised to x. What does this remind you? What does this remind you? Is it not of the form t plus 1 upon t? And there is one nice result in algebra which we have already done, that if t is greater than 0, then t plus 1 upon t is greater or equal to 2. And if t is less than 0, then t plus 1 upon t is less or equal to minus 2. Now, which one you would apply here. Now 2 raised to x is a positive quantity. 1 upon 2 raised to x also is a positive quantity. So obviously we will be using result which is for t greater than 0. And hence I realized that fx, which is 2 raised to x plus 1 upon 2 raised to x, it would be greater or equal to 2. So my right option is B. Let us rule out the other options. Is f a constant function? Obviously not. 2 raised to x plus 1 upon 2 raised to x will not be a constant function. And as I said, if it is greater or equal to 2, obviously it will not be between 0 and 1. So option D is also ruled out. And then fx less than 0? No, because it is 2 raised to x plus 1 upon 2 raised to x. You are adding two positive quantities. So obviously fx is a positive quantity, not negative. So other three options also I have ruled out logically, right? Now let us move to the next one. And the next one is in terms of a new function, which is Signum function. You know, this Signum function is extremely pet functions of most of the examiners. I mean, whether it is given in the syllabus or not, they will define the way I have defined here. That Signum function is that it is 1 for positive x, minus 1 for negative x, and it is 0 at x equal to 0. They will define it and they will ask questions regarding signum of something. Like we have here fx equal to 1 plus fractional part of x. I have defined my f and I apply signum on f. And all my four options are regarding that. Now, first of all, before taking this problem, you should understand definition of Signum function. Answer for Signum function is 1 whenever quantity on which you are applying Signum function is positive. And Signum function's value would be minus 1 if quantity on which you are applying is negative. This particular idea we will be using. Now, when I look at the first option is Signum function on fx minus 1. So what is fx minus 1? Fx minus 1 is fractional part of x. So I apply Signum on fractional part of x. Now fractional part of x is a non-negative quantity. And also if x is not integer, then fractional part of x would be positive, not 0 even. And hence Signum function of fractional part of x turns out to be 1 whenever x is not an integer. Now I try the next one. I find Signum function on reciprocal of fx. And reciprocal of fx means 1 upon 1 plus fractional part of x. Now 1 plus fractional part of x is surely greater or equal to 1. And normally also 1 upon 1 plus fractional part of x. Why greater or equal to 1 or lesser equal to 1? It is positive. That is good enough. Because I had to apply Signum function. And for Signum function, quantity whether positive or negative, that matters. So 1 upon 1 plus fractional part of x is positive. And hence, when I apply Signum on it, answer must be 1. Correct? So Signum function on reciprocal of fx is 1 and not minus 1. So option C is ruled out. You can see the progress how we are making. Now I realize that fx is greater or equal to 1. Why do I say so? Because fx is 1 plus fractional part of x and fractional part of x is greater or equal to 0. So you are adding something to 1 or you may not be adding, but surely you are not subtracting anything from 1. So fx is greater or equal to 1. And hence fx square would be surely again greater or equal to 1. So it's positive. So Signum on fx whole square when you apply, your answer must be 1. And when you apply Signum on fx, it would be plus 1. So obviously option D is also ruled out. So the correct answer is B. So this question deliberately I have taken to make you understand that how we understand Signum function and how you apply it on some quantities, negative or positive or 0. Let us move to one more, the last one for this session. Here, my fx is given to be bx square plus cx plus d, a quadratic polynomial. And there is one identity given, f of x plus 1 minus fx equal to 8x plus 3. That means I'm expected to actually substitute in place of f of x plus 1 and fx, that bx square plus cx plus d. And we are asked values of b and c for which that identity would be a true statement. Now let us start. What will we be doing? We will be substituting first in place of f of x plus 1, the quantity bx square plus cx plus t in place of fx and replace x by x plus 1. And I will get b into x plus 1 whole square plus c into x plus 1 plus t minus bx square plus cx plus t. Now, how many of you can do that mentally? That bx square will get cancelled. I can see that. Cx will get cancelled. Even d will get cancelled. So when you make simplification, you will be getting nothing but 2bx plus b plus c equal to 8x plus 3. Mind you, please, this statement is true for all x. The moment I say it is true for all x, coefficients of x on two sides must match and constant terms must match. And that will lead to 2b equal to 8 and b plus c equal to 3. 2b equal to 8 means b is 4. Substitute that and get your c also. And that turns out to be minus 1. So b equal to 4 and c equal to minus 1 is the correct option. And it is nothing but b. Now all four problems were different. When we meet next time, again another class of problems I will be taking for you. Till then, stay tuned. Thank you.